So when we talk about the performance of a wireless LAN, coverage and capacity play a very important role. In this video, let's talk about a few factors that affect the range of the AP. Okay. So number one is for sure transmission power, right? Transmission power. We know an access point transmitting at 30 milliwatt will have a larger coverage area compared to the one transmitting at 1 milliwatt, right? So more the power, more the cell size or range. The second factor that contributes or that can contribute is the antenna gain. A lot of folks don't make much use of this, but it's very important to understand what this means. An access point transmitting at 30 milliwatt with a 6 dBi antenna gain, okay, it will have a larger or a greater range than the same access point transmitting at 30 milliwatt with a 3 dBi antenna gain, right? So 30 milliwatt plus 6 dBi antenna gain is going to be will have more range as compared to 30 milliwatt plus 3 dBi antenna again, right? So this is going to be less range. So we should try to make use of the antenna again as much as possible. In fact, if we are willing to increase the range for the clients, the best solution is to increase the antenna gain of the access point, right? A lot of people don't know this, but try to rely more on antenna gain than transmission power, because if you have the transmission power set to too high, it can have a lot of implications also, as we've discussed in the course throughout, right? The other factor is the antenna type. uh, Basically the antennas have different coverage patterns, whether an omni antenna or a directional antenna, semi-directional antenna, patch, yagi, all those antennas will have different coverage patterns. Using the right antenna type will make sure there is proper coverage, and there is proper coverage and the reduction in multipath and the nearby interferences. So we need to make sure we have the right coverage pattern antennas, and with this is going to be improving the coverage and reducing multipath and also reducing interference, right? So yes, this is another factor that contributes to the range of an access point. The other factor comes to my mind is the wavelength. We know wavelength is represented by lambda, that's the symbol for wavelength, and wavelength is inversely proportional to the frequency. That means higher the frequency, which means higher the frequency, lower the wavelength, which means higher the frequency or lower the range if everything else remains the same, right? So what I'm trying to say here is that all things being equal, a 2.4 gigahertz access point will have a greater range than a 5 gigahertz access point due to difference in their wavelengths, right? So all being equal, all else being equal, let me erase this and just simply write that a 5 gigahertz access point will have lesser range than a 2.4 gigahertz access point. Okay, so always know this. That's why so when it comes to coverage and when you design a network for 5 gigahertz, 2.4 will anyway adjust accordingly because it has got greater range than that. Then probably another factor can be some physical attributes, that is the physical environment, right? physical environment like obstructions or walls or obstacles, walls, obstacles, etc. Basically, what it will do is it will attenuate the RF signal. There'll be absorption, there'll be some RF propagation behaviors, absorption, reflection, scattering. All those things can also cause a lot of increases the attenuation. Attenuation means absorption of the signal and basically reduction in the amplitude of the wave. So a building with a concrete, for example, a building with concrete walls will require more access points than a building with a dry wall, because concrete wall is denser and attenuates the signal faster. So that's also another thing that you should keep in mind before you design a network. A building with a concrete wall, concrete walls have high attenuation. Dry wall, they have less attenuation for the Wi-Fi signal. So for designing, this is going to need more APs theoretically, and this is going to use less APs theoretically. Yeah, so these are the few factors which can affect the range of a signal of an access point. So when you design network, when you're looking to troubleshoot a network and you're being proactive or reactive, always keep these things in mind. These things are going to really help you take an informed decision and a better decision, and you're going to be saving a lot of critical time and money of the customer when you do when you have this knowledge and you keep these things in mind. In the next video, we will talk about what we can do to affect the throughput and basically the capacity of the network. So we'll talk about that now.